A pleasant day to everyone. Welcome back to my channel. Today we're going to discuss linear motion sample problems. To begin with, I know when you were in junior high school, you learned different types of motions. So when we are talking about motion, this is the change in position with regards to its reference point. So motion can be subdivided into three kinds. We have the rectilinear motion, gravitational motion, and curvilinear motion. Way back when you were in grade 7 and 8, you learned about uniform motion and uniformly accelerated motion, which will be the main focus of our discussion for this lesson. While when you were in grade 9, you learned about gravitational motion, which is the free-falling bodies and projectile motion. And for the grade 10, you learned about the curvilinear motion, particularly circular and rotary motion. Okay, so let's have our main focus for this discussion, which is all about the rectilinear motion, particularly speed and velocity. And before that, let's differentiate first the formula of the speed and velocity. As you can see on this slide, the main difference is the presence of arrow on the formula of velocity and our speed. So in speed class, this is pertaining to the rate at which an object moves, which you're just going to get the total distance traveled divided by the total time elapsed. Well, for the velocity, this is the rate at which an object moves in a given direction. So therefore, as we all know that velocity is an example of a vector quantity. So it's very much needed class for us to identify the displacement using the directions. Another important thing that you must remember is the concept about the constant speed. Constant speed is the uniform change in distance in a given unit time, and it is known to be the uniform motion. So in a different set of time here, you will solve that there will be a velocity which is 3 meters per second. Another is the discussion regarding about average speed. So average speed pertains to the total distance traveled in a given unit time. So you can solve it in using two different formulas. So if the given is the total distance, you just add the distance given over the total time. While if there is 2 point given, you can use the formula change delta D over delta T. So this triangular here represents the change. So that's why we have the formula D sub 2 minus D sub 1 over T sub 2 minus T sub 1. Or in some books, they denote this number as F and I, wherein the final distance minus the initial distance over the final time minus the initial time. So what is the main difference of average velocity with the average speed? So talking about based on the definition, total displacement divided by the total elapsed time. Because as we all know that, just like what I've told you in the previous slides, that velocity is a vector quantity. So therefore, for you to get for the resultant displacement, all you have to do is to consider the directions of a given value for the displacement. So still the same process, total displacement or the resultant displacement divided by the total time elapsed. Another thing is you are familiar with this instrument that you can see in some of the motorcycles or vehicles, no? And this is known to be the instantaneous speed. So instantaneous speed is the speed measured at particular time or in an instant. So this device is known to be the speedometer. Next one for the rectilinear motion is the concept of acceleration. So acceleration is actually the rate of change in velocity. There are different types of acceleration. The first is the positive acceleration, wherein object speed is increasing or the distance covered is increasing. Second is deceleration, wherein here there is a decrease in speed or distance covered. The other one, the change in directions. So equal distances covered, constant change in the direction with a constant speed. That is for the acceleration. In formula, we can say that acceleration is the change in velocity divided by the total time elapsed. So this is the major formula for it. So Vf minus Vi over time, wherein A is the acceleration, Vi is your initial velocity, and Vf is your final velocity, and T is our time. In acceleration or in uniformly accelerated motion, we have three main formulas that we can use depending on what is the unknown in a given problem. So I have here the list of the three formulas, wherein A is pertaining to your acceleration, Vi is your initial velocity, Vf is your final velocity, and T is your time elapsed, and D is your distance covered. So if you're looking for acceleration, given ang Vf and Vi and time, you can use the first formula. But if you are pertaining or looking for the distance and there is the given time and acceleration and initial velocity, you can use the second formula. So if there is no time given, only the velocity, final and initial, and acceleration, you can solve distance covered by the object using the third formula. So it's a matter of identifying the given first for you to use the proper formula for your problem. Okay, so let's try to answer some sample problems. So sample number 1. A rolling ball moves from x sub 1, which is 3.4 cm, to x sub 2, which is negative 4.2 cm, during the time from t1, which is 3 seconds, to t2, which is 6.1 seconds. So what is the average velocity? So since we are looking here for velocity, and there is 2 points used, so let's identify first the given. So our given is x sub 1, which is 3.4 cm. X sub 2 natin is negative 4.2 cm. And time 1, which is 3.0 second. And t sub 2, which is 6.1 second. So find average velocity. So based on our given, we can use 2 points formula. So solution, we have average velocity is equal to x sub 2 minus x sub 1 over t sub 2 minus t sub 1. So substitute natin, we have negative 4.2 cm minus 3.4 cm over 6.1 cm minus 3.0 second. Okay, wait lang, it should be second here. So let's simplify. Negative 4.2 minus 3.4, we have negative 7.6 centimeters divided by 6.1 minus 3, we have 3.1 second. So simplify natin so that we can get the velocity. So we have 7.6 divided by 3.1. The answer is 2.45. So we have negative 2.45 centimeters per second. So that is your average velocity. Okay, let's try to answer sample number 2. A car accelerates along a straight road from rest to 75 kilometers per hour in 5 seconds. So what is the magnitude of the average acceleration in meters per second? So first, let's try to identify our given here. So given, so it starts from rest. So we need to say our Vi is equal to 0 kilometers per hour. So wala, 0. And your Vf, which is 75 kilometers per hour, and the time 5.0 second. Take note that there is the difference in the unit value, so we must convert things for us to have our final answer. And lastly, let's try to have first our unknown. So our unknown, the acceleration. So first, let's try to convert first kilometers per hour into meters per second. So we have 75 kilometers per hour. So you all know that every 1 km is 1,000 meters, and 1 hour is equivalent to 3,600 seconds. Okay, so let's try to put here 1 kilometer. Yung unit na ika-cancel dito yung 1,000 meter using the conversion factor. So, syempre R dito, so 1 R dito sa taas. We have 3,600 seconds sa baba para makancel natin yung mga unit na dapat i-cancel. Yan, then let's try to simplify. 75 times 1,000 divided by 3,600. So the answer is 20.83 meters per second. Yan, since we already have our meter per second value for 75 kilometers per hour, we can now proceed to our solving. So A is equal to VF minus BI over time. So notice that why you did not convert 0 kilometers per hour, sir, into meters per second. Automatic, everything that you multiply to 0 will be 0, diba? So that's why we disregard that also. So we only have here 20.83 meter per second over the time, which is 5.0 second. So your acceleration value will be 20.83 divided by 5.0. So the answer is 4.166 meters per second squared. But if we're going to follow 2 digits after the decimal, so your A will be 4.17 meters per second squared. Let's try to solve sample number 3, but first let's try to read the problem. A drag racer starts her car from rest, so it is from rest, so meaning to say your initial velocity is 0, and accelerates at a constant rate of 10 meters per second squared, so that is your acceleration for a distance of 400 meters, so we have distance here. Question letter A, how long did it take for the car to travel? So, pag sinabing how long, this how long pertains to your time. Okay? And what is the speed of the race car at the end of the run? So, you are looking here for the final velocity. So, let's write the given. Given, we have here the VI, which is 0. And we also have your acceleration of 10.0 meters per second squared, and the distance of 400 meters. Yeah. So from this, we need to solve two things. So letter A, we have the time, and letter B, we have the final velocity. From the two, before we solve for the time, we can use the formula number 3 for VF. So let's rewrite. So D is equal to VF squared minus BI squared over 2A. So since pinapahanap sa atin yung final velocity, solve muna natin yung letter B. So therefore, all you have to do is to derive formula sa cross multiply. So we have 2AB is equal to VF squared minus BI squared. So since our VI is 0, so therefore we can say that VF is equal to the square root of 2ab. So let's try to substitute. So square root 2 times your acceleration, which is 10.0 meters per second squared, times the distance of 400 meters. So your VF is equal to 2 times 10 times 400, then extract square root, answer. So we have 89.44. So we have 89.44 meters per second. That is your VF. So meron na tayong letter B. So proceed tayo sa letter A. So sa letter A, you can use the formula na A is equal to VF minus VI over time. So since we are looking for the time, cross multiply. So it will become AT is equal to final velocity minus initial velocity. As we all know, VI is 0, so therefore we can say that time, divide both sides by A first, cancel it here. So your time is equal to PF over A. Since just like what I've said, yung VI natin dito is 0, so no need to write. Then try natin substitute ng value. So our VF, which is 89.44 meters per second, divided by the given acceleration, which is 10.0 meters per second squared. So unit to be cancelled since we're looking for time, meters, and yung second, and yung squared yung second natin. So therefore, 89.44 divided by 10, we have 8.94. So the time is 8.94 seconds. Number 4 problem. So let's try to answer this. So suppose the driver on the previous example suddenly step on the brake, stopping the car in 3 seconds. So determine the acceleration, letter A, assuming it is constant, and the distance covered by the race car while braking. So for this item, so there is a given time. So what if daw nag-step on the brake yung drivers in 3 seconds? So time, which is 3 seconds. And definitely, since the acceleration is constant, so A natin here from the previous is 10.0 meters per second squared. Okay, then VI, which is 0 meters per second. So we can solve for letter A. Automatic given yan. So acceleration natin dito, 10.0 meters per second squared. So yan yung sagot natin for letter A. Letter B, let's try to solve for the distance. So you can use the formula D is equal to VIT plus AT squared over 2. But since as we all know, our VI is 0, so therefore D is equal to AT squared over 2. Substitute natin. So we have 10.0 meters per second squared, open close parenthesis, multiply with the square of time, which is 3 seconds divided by 2. So let's try to simplify. So we have 10.0 meters per second squared times 9 seconds squared divided by 2. So we have here D, which is 10 times 9 divided by 2. We have 45 meters. So that will be your letter B answer, 45 meters.